Hello and welcome to another tutorial. We are looking at the topic of basically understanding what the object-oriented programming paradigm is at its core, and now we're looking at the interfaces. And we said that before, Java doesn't allow multiple inheritance, but the question is, how do we add different capabilities to a class? And we said that through the inheritance route, it means we add basically we inherit from an already defined class, and we automatically gain access to most of its API, namely all the public or protected ones, right? We don't gain access to the private parts of that superclass, but that's fine. That's how the API has been designed. But then the question is, if we only can inherit or extend one class in Java, how do we gain access to the capabilities of other types? Let's say I have a car that can, for example, drive. But I can also drive other types of objects, right? Not just a car. But then I want to extend a class. Let's say car extends a machine class. So a car is definitely a machine, but but we can also drive a car, right? So there are some types that for them make sense to. Car is definitely a machine. So I'm going to write it here. Car is definitely a machine, and because we have the is a relationship, which means we can go the inheritance route, right? Inheritance route, right? But then the question is inheritance. The question is, there are some capabilities that we can add. We want to add to our class, right? And let's say the machine maybe doesn't have a specific method which is called drive, right? So then a machine just defines the physical part of your car, the engine, the battery, the whatever, right? The typical things that a car can have. But then the question is, how do we add more capabilities? Because if as soon as we extend the machine class, we cannot extend any other class in Java, and that's the reason they introduced the interface, right? Interfaces are mainly developed for this reason, to add more capabilities to a class without violating the concept of basically violating the concept of single inheritance. So interfaces are a way around to go around the multiple inheritance, right? So to basically get close to multiple inheritance. Now the main idea was that interface is like an abstract contract, right? So interface originally up to basically Java 7, I would say it was mainly basically abstract contract, which means you say that my car implements this interface, and for a car, for example, let's say we define an interface drivable. Usually interfaces that add features or capabilities, they are basically end with able. For example, in Java, in the JDK itself, serializable or clonable, for example, right? Able means we are adding more basically capabilities. And once we get more into the details of interfaces, you see that some interfaces usually they don't have any actual contract in them, any abstract method in them that the car has to provide implementation, and they are called marker interface. For example, serializable is a marker interface. It doesn't have a method inside that, but when a class extends that, it gives JVM more information. Because remember, interfaces also basically define types. There are still types. Instead of using the keyword class, you use the keyword interface, but there are still types, right? A type adds more capabilities or more information to your class that you're defining. So as you already learned, objects define their interaction with the outside world through the methods that they expose. And by expose, we mean public API, right? The methods that are defined as public. Anyone outside the class can access those methods and call them. Methods from the objects interface with the outside world. Methods form the object's interface with the outside world. The buttons on the front of your television set, for example, are the interface between you and the electrical wiring on the other side of its plastic casing. You press the power button to turn the television on and off, right? So you have an interface that you interact with your class, with your data. Remember, the job of the class is to provide the footprint for the objects that we make out of that class, and each object holds some data, and you change those data, you interact with these data through the actions that you can perform on that object, and those actions are methods, right? So again, if we go back to the terminologies of when we discuss what is an object, what is a class, these are the really core concepts of object-oriented programming. In its most common form, an interface is a group of related methods with empty bodies. Actually, it's not empty body. You can leave them empty, but up to Java 7, you couldn't add any body. And remember, empty body for a method is still a body. What I mean by that is I can define a method in this class. So public void do nothing, right? Remember, if I terminate with semicolon, the compiler gives me error because it says that this is a non-abstract method and it requires a body. So before the semicolon, you have to open some sort of curly braces and close it. Because remember, a method body is the scope of its code, right? Any code that we, and the scope in Java is determined by a pair of curly braces, right? So and after method, we don't really need a actual semicolon because the compiler knows where the method body starts and where it ends. This pair of curly braces or curly brackets, it completely defines the body, so there is no ambiguity for the compiler. That's why we're not required to use the semicolon. We can if we want to, but however, empty body is different. So this is called empty body, right? Empty body for a method, and you're perfectly allowed to do this. However, nobody is not allowed here, right? So I want to say public do nothing to, this is the second version. I don't add an empty body, I just add a semicolon, right? So the difference is that this method doesn't actually have a body, and the compiler says that, hey, there are only a special types of method that are allowed to not have any body, but this method doesn't satisfy any of those requirements for this for a method to not have a body, right? Not even an empty body. That's why the compiler is giving us a compilation error saying that this method requires a body even if you want to leave it empty, right? So there are certain types of methods, for example, native methods that delegate to the C++ code, right? And the compiler doesn't require you to add any Java code or add any body. So native is one type of that body. If you are an advanced Java user and you don't know, or you're not familiar of what a native method is, I have a full course, more than 50 hours on Java native interface and what is this native keyword and how do we implement the actual body of this Java method in C++ and how the JVM actually reaches out from Java to C++ and calls that code and returns the result back to Java, to JVM, right? So native is one type which JVM or Java compiler treats it as a black box method, right? That is not required to have another body, not even empty body. The other type is abstract. Abstract means this is an abstract method, right? Which means we're not providing any body, but any class that has an abstract method or benefits from the contract of a class, which means it inherits from this class, it has to provide its own body, right? Abstract means this is just a placeholder, right? And which means this method doesn't require to have anybody, but we still get a compilation error. The reason is that if you have at least one method in a class that is abstract, then you have to also declare your class as abstract, which means now you are not allowed to create a concrete instance of this class. You are not allowed to call the constructor of this class directly. You are not allowed to create an object of this type animal directly. Then what are you allowed to do? You are allowed to inherit from this animal class and provide your own implementation for this method. Remember, this do nothing to method doesn't have a body. We didn't define it. Doesn't even have an empty body. It has no body because it's abstract, right? As soon as I try to provide a body for it, the compiler gives me error. It says that, hey, you marked this method as abstract, which means you are now not allowed to provide a body, even an empty body. You're not allowed to do it, because abstract means the inheritance, the people who inherit from this class have to provide their own body, right? They have to be able to override this. So it says abstract method do not specify a body, not even empty body, right? So the whole point here, we will get back to these concepts of abstract method, abstract classes, and now that we're looking at interface, I want you to understand that interfaces are actually equivalent to abstract classes to some sense, to some degree, right? And which means up to Java 7 they were only allowed to have abstract methods. Now the nice thing about interfaces is that because Java already knows that that's an interface, not a class, you don't need to explicitly write the abstract for every method that you define in the interface. And I'll create an interface and show you what I mean by that, but for now the takeaway is that interfaces are like a contract, which is a class that all the methods are abstract and you're not allowed to provide any body for them, not even empty body, right? So there is again the difference between a method with an empty body or a method that doesn't have a body, right? These are two different things. Under normal circumstances, a method has to provide a body even if it's empty body, unless it's an abstract method or a native method, right? In those two cases you are not allowed to provide a body, not even an empty body. So I'm going to provide some empty body. Usually for empty body we just put the pair of curly braces directly after, and then we don't need to put a semicolon here, right? If you feel like your code is more readable, you can put the empty body like this, provide an empty line here, but usually for empty bodies for a method we just put them directly at the same line. Now if I use my Eclipse auto formatter, it obviously puts it on the next line without any space, right? So again, that's the concept of abstraction, abstract methods, right? So an interface is a group of related methods with empty bodies. And again, this is not strictly speaking true, because all the methods by default in an interface are abstract methods, and abstract methods are not allowed to have a body, right? They're not allowed to have a body, not even empty body. So if you define an interface, note that the difference here is that we're not using the class keyword, we're using an interface keyword, right? And we're declaring a type. So so in Eclipse also, in your ID, whatever ID you use, if you want to go to the new method, you have a class or an interface. So instead of using a class, I'm going to say that I'm creating an interface. The only difference that it creates instead of using the keyword class, it uses the keyword interface. And let's animal, let's say basically, let's say we define a mammal as an interface, right? So public interface mammal, and by default interfaces are either public or package level. You cannot have a private interface, for example, just like you cannot have a private class in a typical sense, right? But you can have no basically access modifier. You don't need to say it's public, right? Now obviously the restriction is that in this case, you see my source code is mammal.java. I have an interface or even a public interface, right? That basically the name is different from the name of the source code. As soon as I declare it as public, then the compiler requires me that the name of the interface must match the name of the source code. And again, the same rule applies to classes, right? We can have multiple interfaces. Interface, let's say mammal1, right? We can have multiple interfaces or even multiple classes in the same source file, but the one that is declared public, the name of that one must match the name of the source code. So again, and the difference here is that now this every interface also is compiled. Let's see what is compiled to. Obviously the only thing that the JVM understands is class files. That's why every interface, just like every class, even if we have multiple interfaces or multiple classes in the same source code, everyone gets compiled to its own separate class file. And if I open, for example, this mammal interface, there's really nothing there because it's an interface with the empty thing. So compile from mammal.java, and it also it says which version of JVM, Java 16. public abstract interface dev package. So the full qualified name obviously is package dot the name of the class or type. Remember, interface, class, these are types, right? In the previous lecture, I said that when I say type, it's equivalent to saying class. Now we're introducing more types in Java, and so when I say type, it could mean class, it could mean interface, right? Anything that has one of these keyword, class, interface. Later we see that enums, these are also types, right? So there are keywords that define new types to your JVM, to your Java source code. And then Java is a statically typed language, which means the type of any variable has to be determined at compile time. The Java compiler needs to know what type you're using. And know that in the bytecode, there is something very interesting happening. That obviously we used public, we use the interface keyword, that's the name. Obviously the JVM has, the Java compiler writes the fully qualified name of my type. And again, every type in Java has to have a fully qualified name. And my project is, if I look at my project hierarchy, I have a package or a folder, dev.java, that's the root of my project hierarchy, and then OOP, right? And then .oop, this is another folder, another package inside my original folder or package, and then the name of the type. So this is the hierarchy of the folders. And the reason is that when you launch your Java application in Eclipse, or I'm running my project through Eclipse, and as I mentioned this before, I'm going to say it again. Eclipse, whenever you run a main method in a class, Eclipse creates a run configuration, and it actually configures your JVM. And it tells what the project is, what the root of your project is, and then what is the main class. And the way JVM loads, remember, when you run your application, JVM doesn't load any class unless you actually use that type. If you define a variable of type mammal, JVM goes and searches in your class path. Remember, class path was the concept that we discussed in the earlier lectures, right? In the class path, it goes and looks for a class that has this name mammal. And where does it look for? It actually looks from the root of your project, the way you launch your JVM. In this case, I mean, it's very easy. I just right click on my class, run a Java application, and Eclipse automatically configures my JVM. So that JVM knows which folders to look for, what is my class path, right? These are automatically configured by your IDE. And again, that's the reason I always highly recommend to use an IDE, because when you start learning Java, it's good to not worry about these details, and later on when you get more advanced, you come back and learn them in more depth, right? And so basically JVM actually looks for the class mammal from the root, and then it has to, obviously mammal is not inside my root dev.java folder, it's inside a folder inside another folder. Those folders are separated by dot in the class path. So that's why JVM knows that, hey, mammal, it has to go look into a folder dev.java, and then inside another folder OOP, and that's where the class file is. That's why the compiler actually always writes the fully qualified name in the bytecode. And that's how the classes are found by the JVM. And again, that's the concept of class path. Which folders are added to the class path, right? Class path. These are the folders that the JVM looks into at runtime when it tries to find a class to load into memory and creates objects of those class for you, right? So it's a very important concept. Very important concept. And most virtual machines, like even Python, has a path variable which is called Python path, not surprisingly. For Java, they didn't call it Java path, they called it class path, because it means we're searching for classes. Python path means we're searching for Python modules, Python files, any file that ends with .py, right? All right, so and again, the takeaway at the moment is that every interface, every type in Java, every individual type in Java, whether it's an interface, a class, or whatever, gets compiled to its own separate class file. And the compiler writes the fully qualified name in it. And then you see there is a keyword that we didn't use in the definition of interface, which was this abstract keyword. That's because by definition, every interface is an abstract. So by definition, Even if we don't write the abstract keyword explicitly, every interface is an abstract type. Abstract type means you are not allowed to directly create an instance, an object of this type. You're not allowed to do that. What do I mean by that? So first of all, you can write the abstract in the definition of your type to be more explicit, but that's not required. So abstract here, it's fine. You see the bytecode, the class file didn't change because abstract, it's going to be there in your bytecode whether or not you explicitly write it. So you don't need to explicitly write the abstract keyword. So you don't need to explicitly write the abstract keyword in your interface definition, right? And let's look at the mammal one, for example. Let's open it with the class file viewer. Let's put it on this side. You see, it doesn't have the public keyword. Obviously, if you omit the public, then in the bytecode, it's not going to public, right? But then it still has this abstract keyword, which means every interface by definition is abstract, right? The other thing that I want to point out is that every method in the interface definition, every method by default, so by definition or by default, is an abstract method in interfaces. What this means is that, again, abstract means you don't provide a body, not even empty body. So public, we're going to say void speak, right? And I'm going to just terminate with semicolon, right? Now I just told you that by default you're not allowed to have a regular method because this looks like a regular method, public void speak. But when I added this to the animal class without any body, we saw that we got a compilation error, right? So if I add it to my animal class, I get a compilation error. This method requires a body. So how come in the interface I'm not getting any compilation error? That's because something happens in the bytecode, and the compiler, again, just like we weren't required to explicitly write the abstract, we're not required to explicitly write the abstract method, abstract keyword for the definition of the method, right? Because the method by definition or by default is an abstract method. Up to Java 7. After Java 8, they realize that we need more flexibility in the interfaces. Otherwise, if I add something new to an interface, then because it's abstract, every class that is using this interface has to change to implement the new method, and that wasn't a best way, and that was very rigid and very less flexible, right? So they added more stuff like static methods to interfaces or default methods to interfaces. And unlike the regular methods in interfaces, both of these have to actually have bodies in your interface method, even empty body, right? Again, when I terminate a method immediately by semicolon, it means this is a no body method. This method doesn't have a body. If I provide a empty body, the compiler is going to give me a compilation error saying that abstract methods do not specify a body. So I'm going to copy and paste this here. And then obviously the first question is, why is it that the compiler says that this is an abstract method? I didn't explicitly write the abstract. That's just because this is a regular method inside an interface. A regular normal method inside an interface by default is an abstract method. This is in opposite with classes. A regular method inside a class is by default a non-abstract method, and any non-abstract method has to have a body, even empty body, right? But for an abstract method, we're not allowed to provide an empty body. We're not allowed to provide any body. So I just want you to be very, very careful about this. If I go back to the class, obviously the Eclipse compiler when I save this, Eclipse compiled this and then updated the class file. And as you can see, if I go back to the definition, you see my speak method, it actually has the keyword abstract in the bytecode, which means this tells JVM, hey, this was abstract, so you shouldn't expect any body here, Now we can have from Java 8 onward, we can have other methods like public default. A default method is that now actually a default has to have a body. Even let's call this walk. Let's say every mammal can walk, right? Or eat, something like that. Now the error here is that this method requires a body instead of semicolon. Why? Because it's not abstract anymore. As you can see, the eat, remember, if you look at the bytecode, the speak didn't have any bytecode. It's just a declaration that it's an abstract. But the eat method, this actually requires some interesting bytecodes, unresolved compilation. So the reason is that when you use the default keyword in an interface, it tells the compiler that, hey, this is not an abstract method. So any non-abstract method has to have a body, even empty body. So we can do this, and we're not required to use semicolon. Or the typical notation is something like this. You just provide an empty pair of curly braces at the same line, right? And later on, we look more into the details of what is the meaning of the default method and what can we do for it. But for now, we can have a regular method in an interface which will be abstract by default. You are not required to write abstract, but if you want to be more explicit, you can write it down, right? Whether or not you write abstract, it doesn't change the bytecode. In the bytecode, it's definitely abstract. But for this eat method, that default, you see public void eat. There is no mention of this default. So the default is just something that doesn't translate into anything in the bytecode. It just tells the compiler, hey, this is a default. So the requirement that it has to be an abstract, just lift that requirement, remove that requirement. This is like a regular method in a class, right? Even though we are an interface, this is like a regular method, so it's not abstract. The only thing here is that the reason they added this because they could from the beginning enforce typing abstract on every method of an interface. Then adding no abstract keyword means it's a regular method. But then the original thinking up to Java 7 was that let's not require the abstract because every method has to be abstract, right? So they removed this requirement, but later on they realized that it's good to also have regular non-abstract methods in an interface. So, and Java always preserves backward compatibility, so they decided to add a new keyword, and this keyword was already there, right? Java already had this keyword in the switch statement, right? So they didn't add a new keyword, but they just reused this keyword. So they reuse the default keyword, which is good. I mean, it's good to not add new things, instead reuse the original ones. Instead of reuse, the better terminology is repurpose. Now the repurpose this in the context of interface, right? So this was a very brief introduction to interface. From the next lecture we will look into more details. Please stay tuned, and I'll see you in the next one.